Assalamu alaikum. This is another class on design questions. I'm using the same file which I was using before. And if you have the printout of that file or if you have the digital version, you can use it. You have to open this page number 3 of that file. The converging lenses used in a school physics laboratory are made with a variety of thicknesses and have different focal lengths. The focal length f of a lens can be calculated if u, the distance between the object and the lens, and v, the distance between the lens and the image on a screen, are known. The formula is f is equal to uv upon u plus v. Read the question. Plan an investigation to determine. Let me explain the concept of focal length. If suppose this is the lens, okay, light rays are coming from here. These are the light rays. After passing through the lens, the light rays will combine at a point. This point is called focus. This point is O, and O is called optical center. Now, this distance is called focal length. If any of you have forgotten this concept, it is better to copy this as a revision. plan an investigation to determine the relationship between the thickness and the focal length they have given us the following apparatus. Read the apparatus. You are not required to do this investigation. In your plan, you should draw a diagram to show the arrangement of the apparatus, labeling U and V. U means object distance and V means image distance, which he has explained here. Explain briefly how you would do the investigation. Explain briefly how you would determine the thickness of each lens. You may draw a diagram if it helps you explanation. Draw a table with column headings to show how you would display your readings. You do not need to use the equation to calculate focal length. He says on figure 3.1, you can draw on figure 3.1 also. So this is my lens, and I can introduce a meter rule, and I have a lens stand. So I have a lens stand given in the question. They have given us illuminated object, selection of lenses, screen, meter rule. And a lens holder. Lens holder is that which can hold the lens in its position. It's a holder available. And I have a screen also. This is the stand. Let's say this is all on a table like this. This is the meter rule. And now here you can put the illuminated object. maybe it's a lamp or something like that. So I put it here. This is the illuminated object. And let me place a screen. Now I have placed a lens. I have placed an illuminated object. This distance is u and this distance is v. So please copy this apparatus. Once you have copied it, let me know. First copy this whole apparatus and let me know once you have copied. Now the plan is there. We can change the thickness. We can take different lenses. Independent variable is thickness. So we will change thickness and we will see how focal length will change. Now, how we can find the thickness of the block? How we are going to find in the actual paper, this is a specimen type paper, a sheet, but in the actual paper, examiner is going to give us extra space so we can find easier to write down our answers. Look at this diagram. I will put a wooden block here and I will put a wooden block here. I will read its position on x-axis, on the meter rule, x1, x2, and thickness will be x2 minus x1. This is how I'm going to find the thickness. You have to copy this diagram also. So we have defined in the paper when you are going to solve this question in schools is also part of midterm design question ATP. You have to read these bullet points 2-3 times so that you do not miss anything. He says, draw a diagram to show the arrangement of the apparatus labeling U and V.
Why we need a wooden block to measure the thickness?
Because otherwise the lens is thicker from the center. Actually, the lens is not uniformly thick. If you see the lens in real, or if you wear glasses, you can see the lens is not of equal thickness. So I have to put the block so I can reach the belly of the lens, and from where I can touch the lens, from there I can touch the meter rule. Otherwise, meter rule cannot be placed across the thickness of the lens. Lens is thick at the center, like our eye lens. So as the lens is a circle, it is thin at the circle. So when you put your meter rule close to the lens, it won't be able to reach the belly of the lens. So I will put the 2 wooden blocks so I can touch the belly, and the other part of the block will be touching the meter rule. Now he says, draw a diagram. We have drawn it, explain briefly how to do the investigation. Then he's explaining how you would determine the thickness. Then we have to make a small description of this whole procedure also. Draw a table with column headings. So we will be reading thickness and we will be reading focal length. Now come to the procedure. Now we have drawn the diagram. So you can write anywhere under it, or if you can, if you have a small writing, you can write sideways. Presently, the problem is that this file is our CI specimen question, so they haven't given any space there. So you can write shortly that arrange the apparatus as shown. This is the procedure. Arrange the apparatus as shown. Arrange the apparatus as shown. Move the lens forward and backward. Move the lens forward and backward. Move the lens forward and backward until a sharp image until a sharp image is produced on the screen. Until a sharp image is produced on the screen. This is just like a situation where you want to take a picture from your mobile of a document, something written. You must have noticed that we have to move the mobile a bit upward and downward until our mobile camera shows a very clear picture. Then we snap it. Same here, same procedure. Now continue writing, then measure U and V. Then measure U and V. Then measure U and V. Then measure U and V using the given formula. Find the focal length. This is the formula given in the question. Use the given formula to find the focus. Repeat the trial 3 times and take an average. Repeat the trial 3 times and take an average. Repeat the trial and take an average. Now take another lens. Continue writing. Take another lens. Take another lens. Measure its thickness. Take another lens. Measure its thickness. Measure its thickness. In this way, collect at least 5 readings. In this way, collect at least 5 readings. In this way, collect 5 readings. Now let's make a table. Serial number and focus in centimeter, thickness in centimeter. This is a simple table. Copy this. A student is investigating the factors that affect the height to which a ball bounces when it is dropped. Plan an experiment to investigate in detail how the height from which a ball is dropped affects how high it bounces. It means you have to repeat the trial for different heights and you will see that how high the ball rises. Remember that ball goes very fast. The following apparatus is available. The following apparatus is available: balls of different materials and sizes, sheets of different types of floor coverings, any other apparatus and material usually available in a school physics laboratory. You're not supposed to do this experiment. In your plan, you should list any additional apparatus needed. Give brief instruction for doing the experiment. Describe a precaution the student should take to ensure that measurements of the height of the bounce are repeatable. State the key variables to control. Draw a table with column headings to show how to display the readings. Explain how to analyze the readings to reach a conclusion. So here we can design first you people read this experiment again. You all people, everyone has to read it again. I'm just coming, read the whole experiment again. So we need an apparatus to drop the ball. I have placed a fiducial mark. Fiducial mark is a reference mark, and I'm planning to drop the ball. I'm planning to drop the ball always from this level. I will attach a meter rule along with the ball. Look at the meter rule. I can drop the ball from different positions. I can drop the ball from different positions. Copy this apparatus with me. So I'm planning to drop the ball from the same height and the ball will bounce. I can use a video camera to record the ball motion, because otherwise the ball will drop and rebound so quickly that it would be difficult to record the ball motion. So I can take a sheet, put the sheet on the floor and allow the ball to drop. The ball falls and it rebounds. So one is this height and one is the rebound height. I will use a recording camera, a video camera. I will record the motion by using a video camera. So I will record the motion by a video camera. And now what are the variables? There are two heights. Capital H, the drop height, I will change. And small h, the rebound height. So I have mentioned examiner, I have mentioned him, the variables also. Meter rule, a pointer. a video camera. These are my additional operators. Now I will drop the ball from different heights and record the rebound height. Like this. Then I will plot the values on a graph of H against H. So this will be the procedure. The procedure is very simple. So quickly copy this screen also. Quickly copy this screen.
Should independent variable not be on x-axis?
Independent variable is capital H, from where you drop the height. From where you drop the...
It should be on x-axis.
That is a good point. That is a very good point. So I can correct it. Perfect. The independent variable should be on x-axis, right? Yes, good. Now procedure is very simple. So you people can write the procedure. And I'm just having a quick namaz break for around, I'm just coming back in within 10 minutes, inshallah. So namaz time here. So you people write down the procedure and then you can share with me on the Zoom chat. A very simple short procedure is needed. The whole diagram is there. Copy this. And we are having a short quick break here and I'm coming back. Then we are continuing the class. With me. If you people have written any procedure, please share with me. So what would be the procedure that always you can start that arrange the operators as shown. So now write down the procedure that arrange the operators as shown. Write down the procedure. Arrange the operators as shown. Arrange the operators as shown. Drop the ball from the height. Drop the ball from the height. Use a video camera. Use a video camera to record the motion. Use a video camera to record the motion. Use a video camera to record the motion of the ball. Record the rebound height. Record the rebound height. Record the rebound height. Repeat the trial. Repeat the trial with a different drop height. Repeat the trial with a different repeat the trial with a different drop height. Acha, you have to proceed. Record all the values in a table. Record the values in a table and plot them on a graph. And plot them on a graph. Now look at this question. A student uses an electric heater to heat a beaker of water. She notices that the time taken to heat the beaker of water changes when the voltage across the heater is changed. Across the heater is changed. The power of the heater is given by the equation P is equal to VI, where V is the potential difference and I is the current. Plan an investigation to determine the relation between the power produced by an electrical heater and the time taken to heat a beaker of water. To heat a beaker of water. Following apparatus are available: ammeter, voltmeter, variable power supply, and 250 cm3 beaker, heater, thermometer, stopwatch, any other. You're not required to conduct this experiment. He says complete the diagram in figure 5.1 to show the circuit that you would use. Explain briefly how you would do the investigation. State the key variables to control. Draw a table with column headings to show, and explain how you would use the results to reach a conclusion. Now let's complete this apparatus first, and I am attaching First of all, I am attaching a voltmeter here. I have attached a voltmeter. I connect the wire and I have attached an ammeter and a switch. Then this is the circuit and I have to attach a thermometer and held it by a stand. You have to copy this. Let me know once you have copied it. This is the apparatus and voltmeter is there, thermometer is there. Now we have done this job and we should mention the power of the heater is given by the equation. So you have to make an investment in the ratio between the power produced by an electric heater and the time taken to heat a beaker of water, So he wants me to put a time clock also. So I will attach like this. Put a stop clock also. So what are the key variables? I have a variable power supply, so I can vary the power. Power and time. Dependent variable is time. So I will make a table here, random table. And first I will mention the trial number. I will mention the voltage. I will mention the current. I will mention the power. Theta 1, initial temperature. Theta 2, final temperature. Or we can say that we can, space is finishing for me, so I can take delta theta in centigrade, and then I will measure time. What is delta?
Is temperature the control variable?
Our temperature is looking to be a control variable because we need to make a temperature change, and we can change it by heating, and within a given time, the time will change. So this is temperature change. Copy this everything quickly. So this is the procedure, and we will arrange the apparatus as shown, and we will draw a graph of power against time. We will draw a graph of power against time. So let's keep it up to here, and we will inshallah continue this in our next class. Allah Hafiz.